Hey everybody, Mr. Lake here with another chemistry video. Today we're talking about balancing chemical reactions. So in the last video, we talked about how to just write chemical reactions and how to use the language of chemistry around those. And now we're going to talk about how to make them real, how to make them realistic, how to make them follow the law of conservation of mass in all situations, because that's really, really important. We're talking about balancing chemical reactions. I think you're going to like this. A lot of students enjoy this part of chemistry. It's a kind of a fun, simple puzzle that you have to figure out. So first question, here's a chemical reaction where aluminum and bromine react to form aluminum bromide. So what I want to know is, do you notice what's wrong with this reaction? What you should notice is that when you think about how many atoms of each thing are there, we have one aluminum atom and two bromine atoms reacting to form a compound made from one aluminum atom and three bromine atoms. So the question is, where did the third bromine atom even come from? And the answer is that this didn't happen. This is not how it would go down. This is not a balanced reaction, which means that it's not balanced because there are not the same number of atoms of each element on both sides. There should be always the same number of atoms of each element on the reactant side and the product side. And in this case, that's not happening. So this does not follow the law of conservation of mass. Or the law of conservation of matter. We have a bromine atom just coming out of nowhere, which can't happen. So what we're going to see will be more accurate, is that this will be a reaction between multiple atoms of aluminum and multiple diatomic molecules of bromine to form multiple molecules of aluminum bromide. And this is just a single reaction. So it's not always going to be one of everything, right? It's not always going to be that a reaction is one of this and one of this come together and make one of this. Sometimes it's two of these and three of these come together and make two of these new things. Like in this case, if you had two aluminum atoms and three diatomic molecules of bromine, they could react together to form two aluminum bromide molecules in the end. And that would follow the law of conservation of mass, because in the reactants, we have two aluminums. In the products, we have two aluminums. In the reactants, we have six bromine atoms. And in the products, we have six bromine atoms as well. Everything checks out. So when you balance chemical reactions, you'll notice that this previous one, right, what's different in terms of the actual equation is that there are coefficients, numbers written in front of the different compounds in the reaction. This one didn't have any, and it was unbalanced. This one now has a 2 in front of the aluminum, a 3 in front of the bromine, and a 2 in front of the aluminum bromide, and now it's balanced. So we are going to balance equations by adding coefficients to make sure that the law of conservation of matter and mass is always followed. So coefficients are those big numbers written before a chemical formula, and they just indicate the number of molecules that are present in the reaction. They are different from subscripts. You've been working with subscripts for a while. Subscripts are the little numbers written after and below a specific element and indicate the number of atoms present. What's really, really important to remember is that you never change subscripts. You are only going to determine subscripts if you are determining a compound, like if you're doing the nomenclature stuff, like if you want to know how many aluminums and how many bromines would come together to form a compound, then you've got to cross-drop and you have to determine the subscripts. But in terms of balancing, you're never going to change subscripts. You only change coefficients. Really, really important to remember that. And the steps to balancing a chemical equation, which I'm going to just talk to you about, and then we're going to walk through some examples. And by the way, you're probably going to need to pause the video and take notes along as we go through this. I'd recommend writing this down. Number one, you just have to write the chemical equation. So you need to dig up your knowledge of chemistry nomenclature and write out all of the compounds in a chemical formula first. So you've got to make sure you've got the right chemical compound formulas. You have to make sure you put the reactants on the left, the products on the right, an arrow in between them. You have to make sure that if you know the physical states, you indicate those with the letters in parentheses, and you have to be watchful for diatomic molecules. All of that was covered in the last video. All of that was basically the last video. So essentially, you need to do the writing chemical equations thing from the last video. Then, the way that I do it is I make a T-chart. I make a simple T-chart with space for reactants on the left, products on the right. And along the left-hand side, I write out all of the elements that are involved in the reaction, not the compounds, the actual elements that are involved, the elements within the compounds. And then you just count up the number in both the reactants and the products, and you fill out your T-chart. So if there's oxygen, and maybe there's 2 in the reactants and 3 in the products, you would just write that down. And then maybe there's also sodium, and so you'd write down how many sodiums are in the reactants and in the products. And that gives you the information about what's balanced and what's not balanced. Then, this is where it gets fun. You're going to kind of mess around with coefficients. You're just going to start changing coefficients, adding them specifically, in order to try to get the number of atoms of each element balanced on both sides. And what I do is I update my T-chart as I go along. Again, I'm going to give you some examples. I recommend always starting with the largest compounds and then leaving the smallest compounds, like the diatomic elements, for last, for balancing. And then lastly, this is not always necessary, especially if you kind of like get used to things and you're doing things accurately as you go along. But at the end, you should always check and make sure that your coefficients can't be simplified. So for example, if you have coefficients of 10, 5, and 5, those should probably be coefficients of 2, 1, and 1, right? Because all of those coefficients have a common denominator of 5. Good morning. Hold up a second. Sorry for the interruption, everybody. Let's do an example. So, step 1 was already done for us. We have a chemical reaction written out at the top. Now, oftentimes, I'm not going to do that for you. I'm just going to tell you what the reaction is, and then I expect you to go through the process of figuring out the compounds and writing the reaction. But in this case, I really just want to focus on the balancing. So we've got a reaction that is written out for us. Silver iodide and sodium sulfide react to form silver sulfide and sodium iodide. So on the reactant side, which remember is the left-hand side, there is currently 1 silver atom, there's 1 iodine atom, 2 sodium atoms, because there's a 2 subscript there, and 1 sulfur atom. And on the right-hand side, there are 2 silvers, 1 sulfur, 1 sodium, and 1 iodide. So as you can see, they are not balanced. We've got more silver in the products than the reactants and more sodium in the reactants than the products. So both of those things are the things that we need to deal with. So I'm just going to start at the top of the table. And this is, again, just really like a guess and check type of thing. You're just going to try changing some coefficients and see what they do. So I know I need more silver in the reactants. So I'm going to try throwing a 2 in front of silver iodide. That's going to increase my number of silvers to 2 and increase my number of iodine to 2 as well. The coefficient applies to the entire compound. So if you put a 2 in front of the silver iodide, it applies to both of these things, right? Not just the silver. And you can't this is something that a lot of people do, you can't throw a coefficient in the middle of something. So if you needed more iodines, you couldn't put a 2 in the middle of silver iodide. You would have to put a 2 in front of the whole thing, all right? Okay, so now silvers are balanced on both sides, but we put the iodines out of balance. So we need more iodine and we need more sodium on the product side. And we can do that both at the same time. So if we put a 2 over here, that's going to increase the number of sodiums to 2 and the number of iodines to 2 on the product side. And now everything is balanced. We have the same number of atoms of all of the different elements in the reactants and in the products. So this up here is our balanced, I'm bad at this thing. That is our balanced chemical reaction. Let's do another one, a hard one. Pause the video and try this one on your own. Did you try it? I hope so. Let me show you how this is done. So, our chemical reaction is along the top here. There is 1 calcium, 2 chlorines, 3 sodiums, 1 phosphorus, and 4 oxygens in the reactants. Whew, okay. And in the products, there are 3 calciums. Oh, this is interesting. Remember, subscripts apply to everything in the parentheses. So there are 2 phosphorus and 4 oxygens here. Sorry, 8 oxygens. And then there's 1 sodium and 1 chlorine. Dang, this is all sorts of imbalanced. So I'm just going to start at the top. We need more calcium in the reactants. And specifically, I want there to be 3, so I'm going to put a 3 in front of the calcium chloride. So that increases the number of calciums on the reactant side to 3, and it increases the number of chlorines to 6. Okay, well, now calcium is balanced, but everything else is still imbalanced. So let's move on to the chlorines. Let's just go down the list. We need 6 chlorines now in the products. So I'm going to throw a 6 in front of this. That changes the number of sodiums to 6 and the number of chlorines to 6. Okay, kind of making some progress. We need more sodiums in the reactants now. So specifically, I want there to be 6 so that it balances out with the new number in the products. So if I put a 2 here, that's going to mean that there are now 6 sodiums, 2 phosphorus, and 8 oxygens in the reactants. Whoa! That was magical. That one last little move balanced all 3 of the last elements. So here it is. This is now balanced. What you see along the top is the accurate balanced chemical reaction equation. And that's what I've got for you today. So that's how you balance chemical reaction equations. This is a very, very important video. I hope you were taking notes. If you haven't, make sure to write down some of the most important stuff. I hope you did the practice along with me as well. I'm going to have an assignment for you that's going to be a lot of practice on this before we start talking about reaction types and get further into the nitty-gritty of the math behind chemical reactions. So that's it for today. Take care. I will see you in the next video.